In the second half of 3.1, we are going to use prime factorization to help us find lowest common multiples. Now, before we can do that, we must talk about what are multiples. To generate the multiples of a number, multiply the number by the natural numbers 1, 2, 3, 4, etc. So for example, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, etc., etc. What would be the multiples of 6? Well, it would be 6, 12, 18, 24, etc., etc. Okay, so that's what a multiple is. The lowest common multiple, or least common multiple, is the least number that is divisible by each of the given numbers. So for example, if I wanted to find out the lowest common multiple of 9 and 6, I would look at the multiples of 9, I would look at the multiples of 6, and then I would look at the smallest number that is common to both. And if we look at that, 18 is the first number that shows up in both lists. So 18 would be the lowest common multiple of 9 and 6. Meaning 18 is the smallest number that both 9 and 6 divide into evenly. Let's say we're asked to find the least common multiple of 18, 20, and 30. And again, we're going to use our prime factorization skills. So we'll get 3 different colors here. And first of all, we'll do the prime factorization of 18. And this should be a review from what we did in the first part of 3.1, when we found greatest common factors. And the last one, 30, 3 times 10, 3 times 2 times 5. Now, when we do the lowest common multiple, it is different than the greatest common factor. In the greatest common factor, we just listed the factors that were common, and we multiplied them, and that was our greatest common factor. In lowest common multiple, you have to look at all 3 of the prime factorizations, and we have to indicate every prime factor that there is in the bottom line of all 3 numbers. So for example, you notice there's a 2, there's 2 2's here, and there's a 2 here. It doesn't have to be common, but there is a 2 that shows up. And because in 20, a 2 shows up twice, we're going to write down 2 squared. And again, if you notice, the next prime factor is 3 that shows up in this list going horizontally across. And 3 shows up twice in 18, so it's going to be 3 squared. And finally, the last common prime factor that shows up is 5. It doesn't show up in 18, but it doesn't matter. It shows up at least once in 20, and it also shows up in 30, and there's only 1 5, so I can only put 1 5 down here. So now if I go 2 squared times 3 squared times 5, that gives me a lowest common multiple of 180. So therefore, 18, 20, and 30, the smallest number that all 3 of those divide into evenly would be 180. All right, let's try another one. This question was posed, is there another way that we could find the common multiple? Yes, we could list all the multiples and then look for 180, but again, that's a very tedious procedure. All right, let's take a look at the next one. We want to find the least common multiple of 28, 42, and 63. So again, we're going to do the prime factorization of each of these. So I have 28, I have 42, and I have 63. So 28 is 4 times 7, and 4 breaks down into 2 times 2. 42 is 6 times 7, which is 2 times 3 times 7, and 63 is 9 times 7, which is 3 times 3 times 7. So now we have to look at this whole row here. Those are all the prime factors of all 3 numbers. So to find the lowest common multiple, let's start. I notice I have a 2 here, and it shows up the most in 28, and there's 2 of them, so it's going to be 2 squared. I have a 7, and that shows up once in all of them, so I'm going to include a 7. And the last one is going to be my prime factor of 3. And 3 shows up once in the prime factorization of 42, but twice in 63. So it's going to be 3 squared. And if I multiply those all together, 2 squared times 3 squared times 7, my lowest common multiple is 252. So that is all there is for lowest common multiple. So these are the questions that you need to do for the second half of 3.1 on lowest common multiple. So give those a whirl, and if you have any questions, the answers are posted on the webpage. Good luck.